Okay, 8.5, the remainder and factor theorems. So let's see what these are and how they apply to what we're doing. So it says find p of negative 5 for the polynomial p of x equals x cubed plus 2x squared minus x plus 4. What does the value of your answer represent? So find p of negative 5. So remember, that's function notation. So what does that mean? That means that we are going to plug in negative 5 for p. So we get negative 5 cubed plus 2 times negative 5 squared minus negative 5 plus 4. Either plug that directly into your calculator and have it calculated for you, or you can do it mentally. I don't have a calculator, so I'm going to do it mentally. So negative 5 times 5 is 25 times negative 5 is negative 25 plus 50, because my negative squared is positive. Double negative turns into positive. So I have a negative 125 plus 50, which is negative 75, plus 5, which is negative 70, plus 4. So it looks like p of negative 5 equals negative 66. So if I made a mistake, I apologize, but that's the way I've come up with right now. So negative 66, what does that value of your answer represent? Well, remember previously in the year, I was trying to get you to identify in function notation that this represents the x-coordinate of a point, and the result is the y-coordinate of the point. So what does that represent? It represents the y-coordinate of the ordered pair. If you plug in this for your x, you get this as a result for your y. So that would be able to graph a point on this cubic function right here. Okay, well, it says use synthetic division to solve the above polynomial. So for example, we're going to divide by x plus 5. We're going to divide x plus 5 into p of x. What do you notice? Well, because I'm dividing by x plus 5, which is in the form of x plus c, I'm going to use synthetic division because it's much faster to me than long division. Remember, I put the coefficients in front of, or up here on the first line. So it's 1, 2, negative 1, 4. They're in descending order. I bring down my 1, multiply, add, multiply, add, multiply, add. Hey, there you go. I can check my work from above. So I get negative 66. Well, what do you notice? So I notice that the remainder is the same as the y value when I plug in negative 5. So that then leads us to the remainder theorem. So what does that mean? That means if I divide by a quantity of x minus c, then my p of c, whatever that value is, so in this case it was p of negative 5, right? That will be my remainder, right? If I take the quotient, multiply it by the divisor, and add the remainder, then I will get the overall dividend. So that's only good for an x minus c for any number c. Okay, again, what does that mean? Well, this is it. If I'm trying to find p of 2 and it equals 6, 6 would be the remainder had I done that long division or synthetic division with something that's in the x minus c form. So if I'm putting in a 2, that's the same as saying I'm dividing by, x minus 2. What is this 6? The 6 is the remainder. Should I divide the polynomial, the original polynomial, by this divisor right here of x minus 2? So I'm pretty sure I just said all of that. So let's verify it. Okay, if I'm given this polynomial, well, I'm dividing by x minus 2, so I'm going to put a 2 up here in the corner. My coefficients are 2, 3, and negative 8. I bring down my 2, I get a 4. Bring down my 7, I get 14. And then I get 6 as a result. So yes, I just verified that p of 2 does in fact equal 6 because my remainder is equal to this value right here. So the remainder is the y-coordinate of your ordered pair, which is a point on that graph. Okay, now let's switch gears. Let's look at the factor theorem. What are factors? So is 2 a factor of 24? So yes it is. How do you know that? Well, you're probably saying to yourself, because if I divide 2 into 24, it divides into it evenly. There is no remainder, right? So factors are things that multiply together to get that number. Factors of 24 are 1, 24, 2, 12, 3, 8, 4, 6, right? When they divide into that number evenly. So there is no remainder when you do division. So we can apply that same concept to polynomials. So determine whether x minus 2 is a factor of this polynomial. Again, it's in the form x minus c. So what do I think is easiest? Well, I think synthetic division is easiest. It's in descending order, x to the fourth, x cubed, x squared, x, and then constant. So I'm going to put those coefficients up here. And then I'm going to quickly do my synthetic division. Add, multiply, add, multiply, add, multiply, add, multiply. And here I have my answer. Okay, but what was the question? Let's go back. It says determine whether x minus 2 is a factor of this polynomial. Well, synthetic division showed me that there is no remainder. Therefore, if there is no remainder, then yes, it is a factor. X minus 2 is a factor of p of x. Okay, that was one way of doing it. That was using what I say is just division, the synthetic division that we just learned. What was another way of doing it? Well, we could have found p of 2, right? We could have plugged in 2 to the fourth minus 4 times 2 to the third plus 5 times 2 squared plus 4 times 2 minus 12. If we did all of this and it equals 0, then that would also prove that there was no remainder, so therefore it was a factor of the polynomial. So I could have plugged in 2 for x, and if I got 0 as a result, that's a factor. Because remember, factors are where the graph crosses the x-axis. So of course we want our y to be 0, because that's where the graph crosses the x-axis, which is a factor, which is a 0, which is a solution, all those good things. For me, if I don't have a calculator, I'm going to do synthetic division every time because it's so much faster. If I have a calculator, maybe you just want to plug it in right here. That's really super easy. But you can also do synthetic division. It's totally up to you. So what does the factor theorem say? It says the polynomial p of x has x minus r as a factor if and only if r is a root of the equation, which means if I plug it in, I get 0 as a result. And that's what roots are, right? So here was this process, and I chose really not to do it, although that is the factor theorem. Okay, let's see how we can use this information for other problems. So find a polynomial equation with integral coefficients whose roots are 1/2 and -1, but it's then telling us that -1 is a double root. So I need to go backwards. This is what x equals. X equals 1/2, -1, and -1. So if I'm going backwards, I'm going to do x minus 1/2, x plus 1 times x plus 1, and that equals 0. And now I have to create the polynomial. So how do I do that? I just multiply it all out. Now did I have to do x minus 1/2? No. To make that easier, I should have done 2x minus 1. Then I don't have to multiply everything by 2 later, or deal with fractions as I'm distributing. So in other words, this is 2x minus 1, right? Because if I'm solving for x, the denominator is the coefficient of run of the x, and the numerator is what we have right here. And that would give us x equals 1/2. Okay, so I'm going to go ahead and try to do this. So I'm going to get x squared plus 2x plus 1 if I were to FOIL this out right there. And now I have to distribute, so I get 2x cubed plus 4x squared plus 2x minus x squared minus 2x minus 1 equals 0. I'm combining my like terms. I get 2x cubed plus 3x squared minus 1 equals 0. And this is my polynomial equation. So I could set it equal to p of x, or I can leave it like this. So here we have it, 2x cubed plus 3x squared minus 1 equals 0. Now remember, if we have 3 roots, you should have a cubic, because that tells us how many solutions we're going to have. So what did we do? We worked backwards by creating our roots first and then multiplying it all out. These were our factors, and then we multiplied it out. Okay, how about the second example? I have 1/3 as a root. Solve for all of the roots. So if I'm solving, I've been given one root, but now I need to find the other two, because this third power, this degree, is telling us that we should have 3 answers. So one of the roots is 1/3. Well, if I do synthetic division with that root, then that allows me to get what it's multiplied by, a compressed polynomial, to get my last 2 roots, because when I divide like this, I'm going to get a quadratic. So here's my root. I put 1/3 up here, and now I do my synthetic division. So I should get a remainder of 0, because it's already telling me it's a root. So I bring down my 3. 3 times 1/3 is 1. 0, 0, negative 18. Negative 18 times 1/3 is negative 6. So sure enough, I have a 0. Remember, if we have a 3 here, that was the same as saying 3x minus 1. So in other words, I factored out a 3 and I got x minus 1/3. So technically, what can I do to these coefficients here? I divide by 3. So I have a 1, a 0, and a negative 6. In other words, I have an x squared plus a 0x minus 6 equals 0. So x squared minus 6 equals 0. I can do the quadratic formula, I can factor, but really quadratic formula, or you can complete the square and I solve for x. Well, because there's no middle term, I'm just going to move my 6 to the other side. So x equals plus or minus root 6. So here are my 3 roots, or my solutions. X equals 1/3, right? And that's what's given to me. So my last 2 solutions are positive root 6 and negative root 6. So what did I do? I first divided this using synthetic division to get a compressed polynomial. This is called a compressed polynomial. And then I used quadratic equation. Actually, this is my compressed polynomial. Then I used a quadratic formula, or I complete the square to get my answers. So pause now and try the last one and see how you do, and then you can compare it with mine. Okay, if you're checking, I'm going ahead and continuing. So I bring down my 2. 2 times root 3 is 2 root 3. 1 root 3 plus 2 root 3 is 3 root 3. 3 root 3 times root 3 is 9. Negative 15 plus 9 is negative 6. Negative 6 times root 3 is negative 6 root 3. And indeed, once again, we get a remainder of 0. So my compressed polynomial is 2x squared plus 3 root 3x minus 6 equals 0. This time, for sure, I want to use the quadratic formula. So go ahead and use the quadratic formula and solve. I'm going to pause, or I'm not going to be able to do it in a minute, and you can check your answer with me momentarily. Okay, I didn't check my work, but this is what I got. I got negative 2 root 3 as a final root and root 3 over 2. So my solutions are root 3. Again, it was a cubic, which means I need 3 solutions. Root 3 was 1, negative 2 root 3 was a second, and 1/2 root 3, or root 3 over 2, was a third. So I did negative b plus or minus b squared, that's 27, minus 4 times a times c, so that's 24 times 2, which is 48. We add them together to get 75. The square root of 75 becomes 5 root 3. So negative 3 root 3 over 5 root 3, well, these are like terms, so I can add them. A negative 3 root 3 minus 5 root 3 is negative 8 root 3. Negative 3 root 3 plus 5 root 3 is positive 2 root 3. These cancel to give me negative 2. These cancel to give root 3 over 2. Looks like indeed I am correct. So once again, synthetic division to get your compressed polynomial. Then you do quadratic formula to find your final two solutions. That's it. Bye.